Okay, in this video, I'm going to discuss your algebra skills, but it also kind of helps us solve equations and doing inverse operations and things like that. But really kind of the nitty-gritty, how can you tell whether a function is its inverse of itself? Now I'm going to attack more of the computational material in this video, and we're going to talk a little bit more of the kind of graphical sense in class. We've kind of talked about symmetry a little bit in reference to the graph. We've also looked at the table, but now let's kind of get down to the nitty-gritty stuff of actually finding an inverse function when given a function. Okay? So for example, we have, I'm going to do number 9. These comes from your practice problems here. So if I have f of x, I'm actually going to replace f of x with y, which means the same thing. F of x and y are one and the same, the function, as we plug in something there. Okay, so we have the cube root of negative x plus 3 divided by 2. Now our goal of this particular topic is to solve for, what we're going to do is, we have this original equation here. This is the cube root of negative x plus 3 over 2. Now to graph this thing may be quite difficult, but we're kind of mostly looking from the computational standpoint. So to find an inverse of a function, we're going to switch x and y. Okay? Now we've talked about this as a table. We've kind of shown it as how it works when plugging numbers into a linear equation. Now we're going to kind of get a little bit more extreme here. I apologize. I did not switch the x with the y. So we have negative y plus 3 over 2. Okay, so I've switched x and y, and now it's my job to solve for y. So I need to kind of work towards solving or getting y by itself. And that's what kind of solve by y means. So I have to think completely the inverse operation of everything. So in this case, I start out, I have the cube root. Okay, it's kind of covering everything. So to do that, I'm going to take the cube to both sides. So I now have x cubed equals negative y plus 3 divided by 2. Alright, so the cube root is gone, and notice how I'm kind of slowly dissolving this thing so I get y by itself. Now to get y by itself, I'm going to multiply by 2 to both sides, because that's going to eliminate the denominator here. So I get 2x to the third equals negative y plus 3. Alright, and then we're kind of seeing that near the end here, so we're going to subtract 3. So now I have 2x to the third minus 3 equals negative y, and then my final last step is to divide by negative 1, and that's just going to change all the signs to negative 2x to the third minus 3 equals y. Okay, and so this is the inverse function of this particular function. But how can I ever check? Am I going to make this seem like, how can I know that this is the inverse function? And we're going to test a lot of those in class, but for the sake of this particular video, we're not going to test too much. But I do have a little demo here. If we're kind of looking at this function, let's look at the original function, if Desmos is going to allow us to do this. So for example, we have, let's see if they allow it here. I'm kind of jumping the gun. If we have negative x plus 3, parentheses, divided by 2, let's see, divided by 2, and then on the outside we're going to put to the power of, because it's the cube root, we can put to the power of 1 divided by 3. Now you notice that there's not really a problem with this. No, it's a fine function here. If we look back, let me zoom out a little bit. We kind of got a nice picture here. And let's graph our found answer, which is negative 2x to the third. A little bit easier to graph here. Negative 2x to the third. Negative 2x to the third minus 3. All right. Now we notice this particular function, we look at it and we say, well, hold on just a second here. Let me take this here. All right? And we kind of look at this function and we say, all right, I'm kind of seeing a little bit symmetry going on here. I'm seeing that we've switched the x and y and we've solved for x and y. And now we look at this and we see the graph kind of shows us a little bit of symmetry. We kind of look, all right, it's not necessarily symmetric to the x and y. It's not necessarily symmetric to the x-axis, like if we flipped it over there, but it is symmetric to the y equals negative x. Interesting. Now, what does that mean? Does that mean that they are symmetric? Does that mean that they aren't symmetric? And again, we'll look at this in class in the near future. But for right now, we're going to assume, or we're going to find out that this is symmetric. All right. So next thing we are going to do is let's look at our another function here. All right. I apologize. I'm kind of jumping around a little bit, getting this done for you guys. And again, we'll talk about number 9. It's going to be a great kind of jumping off point in class because we did solve for y. So that's our goal of this particular video, is that we want to solve for y. All right. So we got x, negative x minus 1 minus 2. All right. So again, the process of finding the inverse function would be to switch the x and y. So we have x equals 3 over negative y minus 1 minus 2. Okay, so now you got to use your algebra skills here. We notice that this whole jumbled mess is kind of saying whatever this is minus 2, so we're going to add 2 to both sides. So we have x plus 2 equals 3 over negative y minus 1. And now I'm kind of stuck in a pickle here. How am I going to get that y out of the bottom? Gosh darn it, I'm not sure how to do this. But let's say, for example, I'm just going to kind of look at this and say, well, it's a proportion, so I'm going to multiply both sides. I'm trying things. I'm just seeing if it'll work. X plus 2 equals 3. So what I did is I just I multiplied across, or I took both sides times negative y minus 1, and this is what I end up with. All right. So we'll notice we're still in a little bit of predicament. It's not really helping us too much, but now we notice, well, let's say if I divide by x plus 2. X plus 2. All right, now I notice that I have negative y minus 1 equals 3 over x plus 2. I'm kind of liking what I'm seeing here. I start to see the end line here. And then if I add 1 to both sides, I'll kind of finish my work up here. So I have negative y equals 3 over x plus 2 plus 1. And then I notice again that I need to divide by negative 1. And so I get y equals negative 3 x plus 2 minus 1. So at this point in time, I'm going to assume that this is the inverse function, that we have done our steps, we have switched the x and y, and we have solved for y. Now to prove as to whether it is what something, again, we're going to talk about in class graphically. And for right now, this will be our answer. And we will prove whether or not that is the inverse function in class. Okay? So I've given you a couple... Probably 9 and 10 are probably the more difficult of these example problems. 11 and 12 will act as kind of a nice ease into the process. Again, these particular things, f of x, g of x, whatever it is, h of x, that can be replaced with just y. Okay, so that's the output when you plug a number in. All right, so give this a shot. Have confidence in yourself. I'm sure you can do it. Like I said, 9 and 10 were probably the more difficult ones that we run into algebraically, especially the process of taking it, the variable from the denominator to get it up to the numerator, and that is a process of multiplying both sides by negative y minus 1, and then we switch them back and forth, and then we get to this. Okay, so take a moment, try if you can figure out 11 and 12, and these problems come from your practice problems, so see if you can give it a shot. Again, I'll make reference to the graph we had earlier, and showing you guys the two graphs. We notice that it is symmetric, but think about it. Is that an inverse function? All right? And I will see you guys tomorrow. Thank you.